So now I'm going to switch to slides and put this to.
Oh, yeah, there's this, yes. There we go.
And this, 1 second. Now I will no longer be able to see text, but I think, Christine, you're able to see text. So we've got Christine as facilitator. Thank you for stepping in. So little background on this. I have clients now with my consulting firm, and they're paying me to do work. And that work is in line with my PhD dissertation, 1 of 4, the emerging state actor. And so it's giving me opportunity to go back and work on some of the model structure. I also have upcoming clients that are definitely going to be in the lean space, so that work is not stopped either. In fact, one of my new criteria for clients is how can they help pay for my PhD? It may not always work that way, but I'm hoping to work it as much as possible. I have permission from clients. This is not restricted or classified or anything like this, and it's heavily aggregated. So this is an update to the emerging state actor model that I've been working on, and this is a specific sector of it that I always knew I'd have to go back and touch and fix, and actually was one of the first things they asked for to improve upon. So what problems am I trying to solve with this particular, now this is just a particular sector in this, is one of the challenges is that the original model was always red versus blue in a very aggregate way. It was always ISIS on one side and everyone else on the other, and they're just going after generic population, which is easy for depicting the aggregate, but somewhat unrealistic in the environments where this occurs. First of all, in a lot of these places where this occurs, there's multiple ethnographic groups, and those ethnographic distinctions make sense. The way I represented this in the first model was simply a deterministic scenario loading. I'd load in populations in certain locations and kind of just distribute them that way, which was very deterministic. It was very linear. It didn't have any dynamic feedback. And then they'd sort of allocate based on the map, and I'd kind of keep track of them like you would in a spreadsheet. I didn't like that. It wasn't very dynamic. It didn't allow them to pick sides. It didn't allow the population to shift or have any sort of ethnographic preferences, or have the Sunnis, for example, more supportive of ISIS, but the Shia more supportive of the Iraqi government. And you see in Syria and Iraq, you have these situations where you have multiple actors, and by actor I'm using a non-state actor, which is an insurgent, a rebel group, a terrorist group, something like that, an emerging state actor, which is like ISIS or the Taliban that they've begun to govern, but they aren't necessarily recognized yet, and then a state actor like Syria, Iraq, U.S. coalition partner, Afghanistan. And so you have these ethnographic groups on one side, and then you have actor groups on the other side, and you have a mix of both. So how do you depict this in a way that's dynamic and not too complicated in the model, so you can actually begin modeling this, especially this picking sides. And then the second part is, how does a particular non-state, emerging state, or state actor develop legitimacy in governing a population? In the first model, I basically said, hey, as soon as they get a population, they'll detect a need for more Shura councils, which is based on some ratio of councils to population, and over time, they're just going to create it. And it was a very arbitrary aggregate level view, and it would shift people from coercive power to legitimacy. So it was a delay factor over time, which is perfectly fine from an aggregate level. And doing some more research, I've discovered there's a 3-stage aging chain, which is really a disaggregated view of a delay, that's got coercive power, calculated legitimacy, and legitimacy. And calculated legitimacy is a very important concept because you see this in a lot of countries where people are like, I'm working with this government or with this group, not because I really believe it, but because they can give something to me. I'm participating because I think I'm going to get a gain from my kin network, my tribal affiliation. I'm going to take something. It's a really strategic calculation. It's not that they're buying in like a native true person of that state, raised in that state, will sort of defend to the death. They're basically joining the state with someone at arm's length as a strategic calculation, saying this is the best option now. And that is a transition point to true legitimacy, which is sort of that kind of, I will defend strongly, this is my state, I'm not, I'm very committed to it. And the question is, how do you build those capabilities in the government that shift people along that road, and then how do they shift back, and introducing some more realistic dynamics. So those are the two problems I'm trying to solve. specifically so that you could actually have both sides of the equation represented. In the original model, it was only ISIS. We only had people were in this big bucket of population, and then ISIS would get them and kind of move them between coercive and legitimacy. But the reality is, if you have a failing government, like say in Afghanistan, you may have a government that's failing, and we may defeat ISIS militarily, but they've got no one in the legitimacy bucket. So how do you represent a failing state on our side, even if the other state isn't winning either? How do you have this dynamic representation of the level of governing capabilities in multiple actors at the same time? So this is what I'm trying to solve. This is the original sector model. This is not a causal loop diagram. These are sectors of the model. Ignore the red loop for now. That will show up on the next screen and be accurate. I kind of put these together. But the strategic architecture for strategy dynamics is in the center. The key performance resource stocks. Around it were world model sectors. What the green ones I want to put your eye to, these were things I kind of sketched off to the side when I originally built the model that says this is stuff I want to work on later. These were things I knew I didn't have in the model originally when I submitted it as my thesis. I knew I needed it later for it to be a little more realistic. Working from left to right clockwise, you have in the upper left behavior of, let me mark the mouse here. Behavior of population on resistance and uprising, so the ability of the population to rebel. The behavior of population on choice making and side choosing relative to ISIS destabilization, so they can kind of pick sides and move back and forth between sides, sort of move quickly back and forth. Behaviors of the population on legitimacy of ISIS, and then the behavior of the population on recruiting and desertion. None of these were in the original model I submitted for my thesis. Last summer, when I went to Delft, I had created a resistance and uprising sector. So when I presented in Delft, that was present. You could have the population, if they were insufficient garrison troops, they would rise up and sort of rebel, and that would create problems. So now ISIS had a controlling feedback loop. The bigger they got, the more garrison they had, the more population they had, the tougher it was to keep them in control. So it was a balancing loop that kept them from growing forever. And the three that I introduced with this latest iteration takes care of these three here, is that it represents the choice making and side choosing relative to ISIS destabilization, the behaviors of the population, and it does it by working on this one sector here, governance and population. So I'm not touching down here on desertions and things like that. I'm just going to focus on this sector. So, oops, somewhere around here there's questions I need asked. I'll jump in. It may show up later. The questions and feedback I'm looking for today is specifically on my model. I've got a bilateral aging chain, and I'm wondering, how do you do first order control on a bilateral aging chain with multiple stocks to prevent like a stock in the middle from going negative? I've got some instances at extreme values where it goes negative. That may just be a technical. I'm using simple generic decision rules in combination. I want to make sure I'm using those correctly. They're complex decision rules because I've combined them. If there's feedback of ways to kind of say, hey, you can simplify this while maintaining the integrity of the purpose, which is to depict those three stocks of coercive, calculated legitimacy, and then the ethnographic perception. But if there's simpler ways, I'm open to it. So I'm looking for that kind of, it's model structure feedback for the most part, and we're going to get into that. I'm just kind of moving forward to give some background and jump in there. But that's the feedback and questions I'm looking for. The two theories I want to build in this on one comes from the U.S. Counterinsurgency 2.0, and this was present in the original model. It's just being more aggregated. It's not visible on the screen here, but on the lower part of, there you go. So this diagram basically depicts what these words say, is that legitimacy is a form of power that is built over time. So when a government builds institutions, each of those institutions creates their own procedures, and it's the instantiation of those procedures and as they credibly perform over time that builds legitimacy in the government and reduces the need for coercive power. So it's not just the presence of any one procedure as a set thing, it's that procedure plus its performance over time that builds an accumulation of legitimacy in the perception of the population. So we're talking about perception formation. And this was something that I did not model other than a delay factor in the original. Was not able to model this sort of structure other than just a simple delay. So this is the first theory. It comes from Turnley, who I met at the winter camp. She's an insurgent anthropologist. And this is the work she did for the military for their version 2.0 of understanding counterinsurgency, how a state forms or an emerging state actor. The second theory I want to include comes from Coolant, which is this competition between different actors over an ethnographic group. And he describes this as a competition with the insurgents. What is an counterinsurgency in a nutshell? He says it's a competition with the insurgents for the right and the ability to win the hearts, minds, and acquiescence of the population. For your side to win, the people do not have to like you, but they must respect you, accept that your actions benefit them, and trust your integrity and ability to deliver on promises regarding their security. So David Coolant was the chief advisor of Petraeus. He was the architect of the surge in Iraq on the ground level that was very successful. He's a very well-renowned theorist on counterinsurgency, and you can see here he's writing almost the same thing. It's not a military. Part of the part I cut out is you don't win this by killing people. You win this by creating credible government institutions that deliver on things they promise on. So these two theories I want to make sure are reflected in the model conceptually. And here are the questions. So this slide ended up in the wrong order. How do I act first order control? Bidirectional supply chain with complex decision rules. I use a complex decision rule because I couldn't figure out how to get the stuff moving both ways. Maybe there's an easier way to do that. Are there obvious other ways to structure this that maintains this kind of concept of three stocks and depicting an ethnographic split between two actors? Other ideas, suggestions? So let me pause here before we get into, I'm going to show briefly the different sectors and some of the behavior of the model because the model is operational. But I'm going to pause on the theories and the emerging state actor. I've whipped through a bunch of stuff, but any questions right now before I show the overview of sectors and baseline behavior?
Your first question is very simple to resolve.
Mm-hmm.
You create two flows.
Okay, so I did it right. You'll see.
That's what I did in the farmer bandit soldiers. The two flows and both have first order control.
So I may be missing first order control on one because under extreme, very at the beginning, I have some very minor negatives at the beginning. You'll see it on the chart. It's like it touches negative on the middle stock, but I'll show that.
If it depends on the stock,
yeah,
that shouldn't happen.
Yeah.
It can happen if you have integration error.
I played around with integration, so it may be an integration error.
If you use Strangakuta, for example, or you use smaller DT, and if it disappears, then it's still an integration error.
That's a good check to check. I know my integration is much smaller than any of the time delays because most of my time delays are whole integers and the integration is 0.0625, but I'll check Rudiger whether it's...
Check with the Strangakuta option.
Yeah. So this is the new structure from an overview. I'll go a little more readable in the next ones, but it shows down here is what I'm calling a strand. This is one strand. If this was a full ethnographic group, it would have two strands. So this is the red state, which would be ISIS. A second strand would come off it at the bottom, which would be the blue state. Like so, if this were, say, Afghanistan, the red state would be the Taliban. The blue state would be the Afghani government. They would link at this node of unaligned population. And the overall objective is that I can have a free-flowing population that moves up from unaligned through a coerced population into calculated legitimacy, into governed legitimacy, and backwards under certain conditions, all the way to unaligned and back into the other state. Now, there are certain conditions like military occupation where they can't just join the other side. There are conquests which will dump a lot of from one side to the other. There are deaths and recruitment that will take people out of this. There's lots of little details, and this is a lot of hidden structure just for simplicity. But the overall objective of all of this is to have a free-flowing population move through these sides, and the determinant of where they move is based off a production decision rule, which is I'm using a complex production that affects a cultural perception, which is a double anchor, and I've got a notional finance over here, which is how they pay for putting in place procedures. This is very simplified. In the actual model, this would be tied to their actual finances. So on a brief overview, now into the more depth, this is the single strand. They start with an unaligned population. They gain some by conquest. In this case, they just gain them all for simplicity. So they all started in a coerced population. There's an implicit decision rule that as they begin to reach the threshold for calculated legitimacy, they'll transition over time from coerced at normal time for transition from coerced population to calculated legitimacy. They'll hang out in here until, again, a threshold is reached, which, again, is an implicit decision rule. I used implicit because these are not obvious things. You can't really tell when you've reached that threshold. It's not clear. So there are hidden graphical curves that affect this that are sort of hidden right now from this, just for clarity. On the flip side, you can abandon one and fall back to the other. These are simple explicit rules, and I'll show how they work. This is more in your face. If the government is failing in your face, you can see it, and you abandon it to go back to. You may be saying, hey, I'm a big supporter of the U.S., but Massachusetts is breaking down around me. I'm going to be a little more calculated here, and that's an explicit choice. And it goes back into calculated, and then calculated abandons into coerced. And coerced, under certain conditions, can go back to unaligned. There's some structure I've hidden down here that basically says, are they under military occupation, or is there some sort of like violent group of soldiers that are going to prevent them from going to the other side? You know, if there's no military, they can flow to that other side. They may, become unaligned, and then they may go join the other side. They may stay unaligned. But this is just a picture of the red state. So I'm thinking that this depicts both a manifest structure of the total population, but it also depicts a latent, which is the distribution of where people are at. You can't look out over a state and know immediately where these different people are located. So that's a latent, hidden structure. What determines that when they move is simply a double anchor. And this is a short-term sort of perception and a long-term perception. The short-term perception is used as the government builds up credible processes. This anchor starts at 0. The processes will come in here with an averaging, and this will simply, on a delayed average, start increasing their perception on a 1-to-1 for processes. And that will start to shift people over. We assume right now that for every population in the total pop, you need one procedure, just for simplicity's sake. So effectively, whatever the value of this is, delayed, will become the value of the calculated legitimacy. And that's the short term, hey, government seems to be working over 2-year, 1-year period. I'm going to be somewhat at arm's length, but I'm going to join in. However, it's affected by this deep latency perception, which is what I was going to see as the cultural bias. The Sunnis never liked the Shia government. So you could say, or there's been 30 years of them not trusting the government. And you can make this a drag on their willingness to accept the new government. Plus, if there's an interruption, either because of corruption, someone's attacked the government capabilities, there's a breakdown in infrastructure, this anchor, this deep latency anchor, will drag the short term back. And what this deep latency represents is the number of people who will go to legitimacy. So as this value rises, your legitimate population will shift over. The governance structure is simply.
I have some difficulty with the variable names of the terms like red, ethno, deep, latent, perception, government is.
I'm trying to figure out a way to. I went with these names. I probably named these 50 times. I'm trying to figure out a way that when you have a giant list of variables, everything's located in the same place, and you get some really, and not like a mile long. You get some really mouthfuls as opposed to saying, cultural perception of the red state, which would be an English way of saying that. But then you get, when you order your variables in a list and start looking for them, they get lost in, whereas as this always puts them in roughly the same order. All the red ethnos are going to be in the same place, and all the blue ethnos are going to be in the same place where all the red govs. So I'm trying to figure out a way to order them that is English enough.
Maybe you can define these terms,
Yeah.
it's possible to have definitions somewhere.
Yeah.
I understand we used to, when we used dynamic, actually, we were even more abstract. We used the first letter of each of those terms and got REDL, PG.
Redlish. Sounds like a record playing backward on Ozzy Osbourne. So basically what that says in abbreviation, I will define it, is ethno will actually serve in the ultimate instantiation of this, can be ethnographic 1 through however many, and represents an ethnographic group. So if there's 10 ethnographic groups, I'm not doing this programming, someone else is.
So there's an array?
There could be. I'm only programming one ethnographic group, but it's built. If you were building Syria, you'd have 4 ethnographic groups: Shia, Sunni, Kurd, Alawite. So that'd be ethno 1, 2, 3, 4, each of which would have 1 strand per actor that they might go with. So you're talking about a very large array, and that would be represented as, and each anchor here would be to each actor. So the actors in Syria, we could say, would be simplified: Syria government, ISIS, Sunni rebels that are moderate, and Salafi Takfiri Sunni rebels, like the Al-Qaeda-backed one. So that's 4. So this would be, we could define colors or numbers, but red would be ISIS, ethno 1 would be Sunni, deep latent perception. And it might then be amber or something, or you could say Syria, ethno 1, and that would depict how the Kurds felt again. You could start doing a big subscripted array to do multiple ethnographies versus multiple actors.
So red and ethno are 2 dimensions.
They are 2 dimensions, right? That's a good way of putting it. There are 2 different subscripted dimensions. They are the only 2.
And are deep and latent also?
That is only referring, maybe that needs to go, but that refers to, and you've seen me use this before, and I'm open for getting a standard name, this double anchor. One is latent, that there's a time delay of someone's perception formation, but the deep latent is the cultural impact that drags the time delay of perception. So we can form a short-term perception of the government.
Deep latent sort of precedes latent. Right.
Yeah, latent happens in a short term, deep latent happens in a very long term.
So
and it's so, and the way I've defined these with your parable and archetypes to think about it is each level of latency is a policy resistance to the previous level of latency. So you think about the latent structures. Why aren't people becoming happy with our government? We're doing all this stuff. Well, there's a latent drag, right? You got to convince them for a while. Well, we've convinced some of them for a while, but then it stopped and they all reverted. Why did they revert? Well, there's a deep latency.
They're like short-term legitimacy and long-term legitimacy, right?
But it's
perception, short-term perception and long-term perception.
Yeah. Okay.
And
short-term.
I'm just trying to understand.
That actually I had those short-term and long-term perception.
Yeah. And then the red and ethno will be subsumed in the
arrays, the dimensions. Yeah.
In the dimensions.
So short-term, and would it help to, because like these last ones actually refer to the stock that it's going to move. So this is, if we called it red ethno, which are arrays, short-term perception, calculated legitimacy, whatever values in this is going to move the stock of calculated legitimacy, whereas this one is going to move the stock of government. Is that useful to kind of indicate what stock it's going to move elsewhere in the model?
That would be reflected in the information link, and actually it might be moving other stocks too because
the
connectivity.
Right. So
it's.
I do have shadow links of these to those stocks.
Yeah.
In the implicit decision making, these are what feed in to the.
So you are in some ways also trying to include the decision tree in the nomenclature. I
that's true.
That's too much, maybe.
Yeah, because mainly the challenge is there's one way to name things for clarity, which I could really easily do. But then there's managing these variables on the back end. And as you know, the ISIS model, the emerging state model, even simplifying it down, has a lot of variables in it. I'm trying to figure out how do you organize those variable names for ease of finding them and working with them so they're sort of like, I know where all my time delays are. I know where all my normal variables are, so I can kind of look for them in the same place.
If you name them like this, it's clear only to you.
Yeah, so I'm trying to think, what are, Saeed, any ideas? Or other, yeah, because that's the challenge. Like, I guess clarity, ultimately, clarity here is more important for the observer, the audience.
Yeah.
That's good.
So I would just say short-term perception of legitimacy and long-term perception of legitimacy. Won't worry about what these are facts, because eventually you'll have the information links.
Yeah.
They're showing that
the computer will know.
Computer will know. And well, if you have a hierarchy, then in that hierarchy, the visual links will appear.
I guess that's true. It will show, and on subscript it will say.
And then you have the red and ethno as subscripts.
Right.
And that is more understandable, at least to me.
Christine, Saeed?
No comments here.
Mark the date and time. Thank you, because that has been a real struggle for me, is how do you organize large variable models for clarity and for the modeler using them? So.
If you organize it in a hierarchy, say there are modules, and then there is structure within modules. That's two-level, but there can be modules within modules too, if it's a deeper hierarchy.
Well, yeah. So I've got sectors. So I can do that. Yeah, Vensim just isn't good at separating.
So you're using Vensim. You're not using Stella.
This would break Stella, as far as I know. It's got several hundred equations.
The Stella.
Well, are you architect? Okay.
And that's. I mean, for visuals, it has that hierarchy.
Right. For visuals, I think it's very. It just seems it was
and
very.
It has almost everything.
It's always been my experience is it seems easier when building in the lab to use Vensim, and I think Said and I have discussed this. It feels easier in the lab, so to speak, to build using Vensim and then switch it once you've got it all figured out and you know what it is, to then switch it to Stella Architect than it is to build it scratch with Stella Architect when you're doing a lot of revising and back and forth. Maybe that's.
It's because maybe you started with Vensim.
Possibly. It also may be my computer is not as graphically powerful, and so the delays with the graphics of Stella, which is a computer-based thing, not a Stella-based thing, that may be another thing too. Okay. The governance structures. What builds the institutions or the procedures is simply a complex decision rule that's a production tied. Basically, this is the producer tied to resources down here. This was interesting because I wondered if this was correct, but it's an implicit decision rule based on adequacy of procedures relative to population. But since it starts at 0, and so this is basically, it happens based on the size of the procedures. It kind of grows organically as we recognize there's more population. It kind of sort of grows. But there's also an explicit that says, hey, we've got a gap here. Let's close the gap. And what it also does is it allows it to start at 0 and have something kick it off. Because I've noticed with these implicit rules is when it starts at 0 and it's a percentage of growth, like this structure here is the multiplier times 10% or some percent of the existing, kind of they're representing the growth. If it starts at 0, this will never grow. But an explicit structure here kicks it off with a little bit, and then this rapidly takes over with. But is that a correct complex rule, or?
So okay. There's a basic structure and there's a multiplier.
Yep. And this way you could also say too, you could say, hey, an insurgent doesn't ever start governing. and they'll never become an emerging state actor because this will remain at 0, and all they will do is their population will stay coerced. The money is just a simple one where for every new process you create, it goes into expenses you have to maintain. You've got a decay factor over here. I said every 20 years a procedure needs to be replaced about. So there's a constant outflow of replacement. You've got tax revenue. In the initial state, it's sufficient, and there's an adjustment to procedural spend. In the initial state, there's sufficient money and tax revenue that nothing, it doesn't matter. However, if there's less money than necessary, this adjustment to procedural spend will stop new procedures from being created, which has an effect of lowering the procedures and thus decreasing those anchors, which will shift population back. It represents the government failing to be able to provide services, if over a period of time. It will not affect the maintenance now. They'll just go into debt. I don't have a maintenance version of it yet, but it's sufficient now to show if there's significant corruption or a loss of money or there's something attacks the capabilities, they can't provide sufficient services, and a sophisticated civilian population will begin to defect out. They'll opt out.
So that stock, red state reserves can go negative.
Yes, it can for now because finances, you can go into debt. You know, you can force things to happen. I'm not really sure how much negative I want it to go or whether I want it to have 0 or some other effect, because there are things that sometimes work in these insurgent states where they can do things without money, but I'm not sure if I want to get into that or just say, look, when it goes to 0, everything stops and breaks down. This is also a proxy right now for the more sophisticated financial structure I have in the existing one, where I'm just going to link it in to their rules. And I think in that one I have some more controls where they have a lot of levers to pull in terms of reducing their military activities, reducing their bombings, and they may try and adjust as they get closer to 0 to sort of not go negative. But I'll show you, there's a behavior I want to show that uses this structure to kind of show what happens when they don't have enough money. So baseline behavior, this is a scenario where they conquer in a pulse. They conquer 10,000, so all 10,000 moves from unaligned to conquered in one month or something like that. They start in the conquered or the coerced population. Here it's red. They shift over time into calculated legitimacy, which is the blue, and then the calculated legitimacy over time shifts into legitimacy. And you can see here these three are sort of transitioning one to the other, and you can see the population begin to shift over time. These are not actually these periods. It's just notional. It says month, but 200 units of time. Over time, most of them become legitimate, and you can see why is that the two anchors, both of which start at 0, they begin adjusting to the increase in processes, which will begin shifting this population over first to the latent, will move these folks over to calculated, and then deep latent will move these folks over to legitimacy. So it's simply showing that it works. As you get people and you start building government, they start moving over to legitimacy over time. Fairly simple. What happens if you introduce a shock to the finances? This is the behavior. Is if I said it's kind of significant corruption, but I just basically lowered the government capabilities at time 100. I took out, they basically already had a running government, and then I took out a bunch of procedures as just a step function. So it was a complete reduction. And it was a vertical reduction. It wasn't a ramp or anything soft. It was just kind of taking out a bunch all at once. But it shows here, so these are comparative, so it's a little bit messy, but it shows there's no change in any of the test versus the scenario, except this is when the procedures get taken out. What you see is the legitimate population draws down in a nice bumpy fashion as the calculated legitimacy moves back up. This represents that, hey, we had a bunch of legitimate population. They saw the functions go down, so they opted out and shifted back down to calculated legitimacy. The population said, whoa, you got some on, but not all of them, some of them. And you can see that reflected here in the anchors, that instead of getting up and staying at top, they dropped down to a lower level reflective of this new kind of lower procedural capability. And it simply was a test to show, hey, does this actually work? You can fill it up and then draw it back down with reduced procedure. And that's it. I can go to the model now and show the actual model. So, questions so far? Ideas, comments? Okay, I don't know if that's visible. This is the Inventsem. This is the structure with all the clarity. When I drop down to, I think, 2, here, let's zoom in a little bit. So you can see here when I add a little bit of detail, there's still some things that are missing. But this is that production loop. For example, you can see that adjustment to procedural spend feeds back in here. Required institutional procedures, the population, this is determining the adequacy for the implicit loop. But I wanted to go down here because this is where I was having a problem. Oops, I got a comment over something. So this is the implicit structure. That latent perception, which we call short-term perception, simply feeds in, and since we know that each population in this version needs 1 procedure per population, and calculated legitimacy is a delayed recognition of the current procedures, this short-term perception is compared to the current population as a gap. There's a table out here that uses sort of an S-shaped curve as percentage gap, and then that comes in and determines how much transition it will be to the normal time, and that moves a population over from coerced to calculated legitimacy. So they move over via an implicit function. The abandon is they look at the actual current procedures, and if there's a gap, they will revert back. So I guess it's possible that they could have some people moving over based off the delayed implicit, while at the same time some are leaving based off the current gap. And I think it's in this one that I sometimes get the negative. Gotta stop looking at the screen, make me dizzy.
You have first order control on both sides, right?
See, and it's right down here. It starts at this -50. And I don't think it does that anywhere else. I think it's only...
So, it starts at -50. What's the initial value there?
The 0, I believe.
Huh.
So it goes to 0. When we look across here, it goes negative. Really early on. And not for long, just for a couple of DTs. And then I believe that's it. Just in that very first instance, it goes in before it even hits DT2. So let's check you said to check the, it's got Euler, you said try Rutger?
Try RK4 fixed.
Fixed.
Still -50. So,
Yeah, it even started earlier. I can show you the table.
That flow, can this flow go negative at any point?
Well, it's a biflow, I guess, and the if you view the table does have negative values, and that may be it. But it's, let's see, if I show all, this is the table here, and this is the negative. So it does have negatives in here, I guess, because originally I was trying to figure out how to do a biflow to draw out population, but then I added that explicit one. So are you saying just cut off the negative, that basically as it approaches 0?
Yeah, I think that if it's only affecting
one flow,
then there's no reason for having negative there. That might be a problem.
Okay, so let's
You have some negatives there also.
I think I fixed it. Let me check.
Oh, there's some negatives.
Oh, I see where it goes to.
So it goes from 0, 0. You might have to redo that table.
So if I delete this and go as graph, I would make a mistake. So how do I get it to recalculate that front part?
Yeah. I think you still have some negative values.
That may have fixed it.
Like you just need to redraw those tables.
That may have fixed it though. Yep, that seems to fix it.
But there are still negative values. You got to clean up those tables.
Okay, clean up tables. Okay, but so basically, even though it's a biflow, I don't have to go negative on an S-shaped curve.
It's not a biflow. I mean,
just make it a single flow.
Well, I mean, it's a biflow in the sense that if the logic tells it to go negative, it would go negative.
Right.
But basically, you are specifying that graphical function to provide first order control on the outflow.
Mm-hmm. And then so the first order control is through here.
Yeah.
And also through here. Okay. Because this one has first order.
And, that means if the stock is 0, the influence will be 0.
Right.
And it will not be negative.
So
go ahead.
I think that's flow by nature is as Professor Said mentioned, should be 2 different flows. However, if you want to summarize, I mean, if you want to save some space in terms of graphics, the only way you can do that is to use minimum and maximum functions inside the flow. So
I wouldn't advise that.
Yeah, I try and avoid those, but I mean, I've done it in the past.
So there is no other solution here. So.
Oh, okay. Yeah, it is a draining function. So there's because it's a percent drain, it should have first order control on everything that is before it. It should be unable to pull out a negative.
That graphical function should not go negative.
Okay.
That's provides the first order control. So that means if the stock is 0, it should be 0. There is more stock, and it should be more than.
Okay, well that's a fix then.
Yeah.
Okay. And so the structure, so that's a big relief too, because I was wondering if this was an appropriate structure to have one flow in and another flow out. I mean, I know this looks to me like the rework loops, or in some ways, so I mean, I guess it's kind of appropriate, but I was just wondering for an aging chain whether it was okay to do this. I checked, as long as it always stays at 10,000, assuming people don't die, I got nothing that should remove it. As long as the total in there stays at 10,000, it works as a material chain, right?
It's not. I mean, it's a flow. Yeah.
Right. Or should it not be call it a material chain? Because I think of it as it's moving people along a supply and then moving them backwards. But their states of being.
Call it what you like.
Professor Said says, don't sully the names, Tim. Stop ruining the names of things that are well defined. Okay. And that's, I mean, this is really what I've been working on the last week or two. So that's kind of all I had to present on. I'm trying to think of, sorry, it's cluttered now. But yeah, everything is fed back. So this one goes directly down into here. And this government one feeds back into this stock here. So there is feedback loop. It's all relatively endogenous, except for the only thing that's not endogenous is your external tax revenue and that initial pulse of how many course population you get. Everything else is endogenous. to the system.
And if you represent it in the stellar hierarchy, it'll show. As it show.
Good opportunity to learn stuff. Another opportunity to improve. Questions, Saeed, at all?
No.
Good effort.
That's all I have. I mean, I don't have. This is hot off the presses today, and last couple of days working on it. So we may call it then and stop recording. I think we're going to take a vacation the next, unless we have. Are you in town next week or?
No, I'm going back.
Okay. Then we'll definitely take one during the society conference, which is 2 weeks out. We may take one next week too. So.
And do come to the university's reception.
Yep, we'll look that up. We'll post it. We'll post it to the SD
I
file.
paid $1,500 for it.
It's almost as much as registration. All right, I'm going to go ahead and stop recording.
Okay. Thank you so much.
It's fun.
Have a good day.
Thank you, Saeed.
Yeah, you take care, Seth.
Thank you. Bye-bye.
Donut, yes. I get to have my lunch.
I already had my lunch, and they had free ice cream, and they had raspberry sorbet.
Today I brought my lunch from home.
So I'm pretty full.
These are some of them are friends.